Okay, I think we're going. Good, camera's on. So what I'm going to do is I'm going to go over the AP Chem Lab for calorimetry. Our purpose is, can we find the standard enthalpy of formation of Mg2+. Pre-lab, other than writing a procedure, the purpose of the lab, any research needed, your pre-lab should address these questions to prime your brain for what we're doing and to keep us on point. So in your own words, explain the term enthalpy and enthalpy of formation. So I'm going to leave that to something you can look at up in the textbook and put in your own words. If I give you the words, that would be would undo that. Also, standard state. That's what that little circle, when you see a delta H, that's enthalpy. That's the enthalpy of formation. And remember, the only thing I want to point out that may not be super clear in the book is that the heat of formation, the change in heat of formation, the amounts assigned 0 are given to those states that occur at standard state. And standard state you can find on page 254. Yeah, so you're all good there, hopefully. Then it says, write a chemical equation whose delta H is the heat of formation for Mg2+. So, what they're trying to say is we want a chemical equation. We want an enthalpy that is equal to the heat of formation for Mg2+. So there's a couple of different ways to look at that. You can look at the enthalpy for the reaction. Mg going to Mg2+, where you take the enthalpy of formation from the reactants and subtract the products. Or, I'm sorry, take the products and subtract the reactants. So we could use the whole direct method and say, oh, it's a summation of N times the heats of formation for the products and subtract the summation N times the enthalpy change for the reactants. So however many moles we have times the heat of formation for the reactants. Since we have MgS and that occurs at 0, we can assume that the heat for the reaction is going to be equal to, what I'm trying to say is if we plug these in, it would be products minus reactants. The reactants heat of formation is 0 because magnesium occurs at standard state like that, and then you can look up the heat of formation for the products in the book, and that's what I'm going to do. That's our question would be like, why can you just call the heat of formation the heat of formation, the enthalpy the same as the heat of formation? It's because one of our things is at standard state and given 0. So to be clear, I'm going to go back to the textbook. I don't have these memorized, so I go to the textbook, and you can see that the heat of magnesium solids heat of formation, this is on A10, appendix 3 of your textbook. Magnesium at solid heat of formation is 0 kilojoules per mole. Magnesium 2+ is negative 461. So when I ask you to write a chemical equation, the chemical equation is just going to be this simple. Mg solid becoming Mg2+, and to balance it, we'll learn this later, but there's also 2 electrons because we're going to be talking about oxidation states. But there it is. And since this is 0, the enthalpy change from our textbook that we just looked at for magnesium is equal to negative 461.96. So Jeremiah came in with a phenomenal question on the post lab and was kind of curious about what's happening to everything else for the overall reaction. So I'm gonna get into that real quick. But let's just look at the components. That's why we have the pre-lab questions, to prime your brain. Similarly, we're going to now find the delta H for the reaction of H plus. So we have H2 going to make 2H plus. Once again, plus 2 electrons. But we don't have to worry about that for now. So we can go look at our enthalpy changes for this situation in our book. What do we find? We find that H2, on the same page, H2 gas, which is our product, is the enthalpy of formation is 0. And so is our reactants, 0. So the enthalpy change that we will use later for this situation is basically 2 times 0 minus 0 equals 0. No change in enthalpy for the ionization of hydrogen. Also, no enthalpy change for the reverse reaction. That would be true. Good. So it says write the chemical equation and net ionic equation for the reaction you will perform. So I put this on the board, and we haven't learned about net ionic equations, but the total reaction, so we're now on number 5. We have magnesium, solid. We're adding that to HClAq. And this is a single bump, right? We know we're going to make MgCl2+. Mg2+. Yeah, I can't speak very well. I'm so dang tired, guys. I'm sure you are too. And then plus H2 gas. The net ionic equation. So the point of a net ionic equation is to get rid of stuff that is unchanged. And that's to write everything as an ion, look at what's actually reacting, and get rid of everything else. So I'm going to rewrite anything that's aqueous into its ionic components, because it means it's dissolved in water. So guys, remember when you have a Cl minus floating around and it's aqueous, it literally is not stuck to the H once it's dissolved in water, but the positive ends of the water is solvating it. This is partial negative, this is partial positive, and so all the little H's will just kind of sit down all the way around it. So what we're doing is we're looking at that as an ionic situation to see if we can follow what is actually happening for the reaction. So here we go. We have Mg, solid. We're going to write it all as ions. H plus Aq plus Cl minus Aq. And you guys should not know how to do this. That's why I was just doing it for you and had you copy it on the board. But let's go ahead and learn this. We're going to learn it anyway sooner or later. And we have Mg2 plus Aq plus C2 plus 2 Cl minus. Should be a 2 here. We didn't even balance it. What's wrong with your teacher? Here we go. And there should be 2ClAq plus H2 gas. And the whole point of writing this way is you can see what has changed in the reaction and what has not changed in the reaction. So magnesium went from Mg to 2+. It definitely happened. Something happened. It lost 2 electrons. We have 2 H's going to H2. Those gained a couple of electrons. Something happened. The C2Cl are still Cl. We call these spectator ions. They have very little to do with the overall reaction. Meaning, if it started out one way and it ended up one way, we don't expect it to produce heat nor require heat to happen. Okay. So then it says for the reaction of Mg plus HCl, what would you predict? Endothermic or exothermic? Honestly, get your brain primed. Oh no, I'm sorry. 6. How could we qualitatively determine endo or endothermicity in a chemical reaction? Okay, if your hand goes on it, that's your hand, and it has heat energy entering it, that means it had to have exited the system, and this is exo. So if it feels hot, remember cold, there is no cold energy, it's just the perception of heat leaving the hand. So if it feels cold, that literally means your receptors having energy leave your hand and enter the system, and this would be endo. And you can write if it feels hot or cold. And what do you predict? You guys can predict that. That's not a big deal. So let's move to the analysis. I was going to do this in 2 videos. I think I'm going to. I'm going to hit pause, post this baby, and then go to the post lab.